adjective pertaining to the moon is luna, derived from the Latin word for the moon, no. The adjective Selenian /Selenian /26, derived from the Greek word for the moon, sel, and used to describe the moon as a world rather than as an object in the sky, is rare. 27, while its cognate Selenic was originally a rare synonym, 28, but now nearly always refers to the chemical element selenium. 29. The Greek word for the moon does however provide us with the prefix seleno, as in solnography, the study of the physical features of the moon, as well as the element name selenium. 30. 31. The Greek goddess of the wilderness and the hunt, Artemis, equated with the Roman Diana, one of whose symbols was the moon and who was often regarded as goddess of the moon, was also called Cynthia, from her legendary birthplace on Mount Cynthus. 32. These names Luna, Cynthia and Selene are reflected in technical terms for lunar orbits such as Apollune, Pericynthian and selenocentric. The astronomical symbol for the moon is a crescent, a 3/4. For example in M lunar mass, also ml. Geological history. Formation. Isotope dating of lunar samples suggests the moon formed around 50 million years after the origin of the solar system. 33, 34. Historically, several formation mechanisms have been proposed. 35, but none satisfactorily explains the features of the Earth-Moon system. A fission of the moon from Earth's crust through centrifugal force, 36, would require too great an initial rotation rate of Earth. 37. Gravitational capture of a preformed moon, 38, depends on an unfeasibly extended atmosphere of Earth to dissipate the energy of the passing moon. 37. A co-formation of Earth and the moon together in the primordial accretion disk does not explain the depletion of metals in the moon. 37. None of these hypotheses can account for the high angular momentum of the Earth. Moon system. 39. The evolution of the moon and a tour of the moon. The prevailing theory is that the Earth-Moon system formed after a giant impact of a Mars-sized body, named Theia, with proto-Earth. The impact blasted material into orbit about the Earth and the material accreted and formed the moon. 40, 41. Just beyond the Earth's Roche limit of (2.56 r. 42, giant impacts are thought to have been common in the early solar system. Computer simulations of giant impacts have produced results that are consistent with the mass of the lunar core and the angular momentum of the Earth-Moon system. These simulations show that most of the moon derived from the impactor, rather than the proto-Earth. 43, however, more recent simulations suggest a larger fraction of the moon derived from the proto-Earth. 44, 45, 46, 47. Other bodies of thinner solar systems such as Mars and Vesta have, according to meteorites from them, very different oxygen and tungsten isotopic compositions compared to Earth. However, Earth and the Moon have nearly identical isotopic compositions. The isotopic equalization of the Earth-Moon system might be explained by the post-impact mixing of the vaporized material that formed the two. 48. Although this is debated. 49. The impact would have released enough energy to liquefy both the ejector and the Earth's crust, forming a magma ocean. The liquefied ejector could have then reaccreted into the Earth-Moon system. 50, 51. Similarly, the newly formed moon would have had its own lunar magma ocean. Its depth is estimated from about 500 km, 300 miles, to 1,737 km, 1,079 miles. 50. Oceanus Procellarum, Ocean of Storms, Ancient Rift Valley's rectangular structure, visible topography Grail gravity gradients, Ancient Rift Valley's context Ancient Rift Valley's close-up, artist's concept, while the giant impact theory explains many lines of evidence, some questions are still unresolved. most of which involve the Moon's composition. 52. In 2001, a team at the Carnegie Institute of Washington reported the most precise measurement of the isotopic signatures of lunar rocks. 53. The rocks from the Apollo program had the same isotopic signature as rocks from Earth, differing from almost all other bodies in the solar system. This observation was unexpected because most of the material that formed the Moon was thought to come from Theia, and it was asserted in 2007 that there was less than a 1% chance that Theia and Earth would have had identical isotopic signatures. 54. Other Apollo lunar samples analyzed in 2012 showed the same titanium isotope composition as Earth. 55. Which conflicts with what would be expected if the Moon formed far from Earth or was principally derived from Theia. These discrepancies may be explained by variations of the giant impact theory. For instance, a high-speed drive-by hit by the impactor could have allowed it to return to Earth a second time but more slowly, and mix more thoroughly. 56. This hit-and-run and return scenario could explain some of the apparent contradictions between material evidence and other theories. 57. A lunar geologic timescale. Millions of years before present physical characteristics. The Moon near side of the Moon, far side of the Moon, lunar North Pole, lunar South Pole. The Moon is a very slightly scalene ellipsoid due to tidal stretching, with its long axis displaced 30 degrees from facing the Earth, due to gravitational anomalies from impact basins. Its shape is more elongated than current tidal forces can account for. This fossil bulge indicates that the Moon solidified when it orbited at half its current distance to the Earth, and that it is now too cold for its shape to adjust to its orbit. 58. Size and mass. The Moon and selected moons of the solar system with Earth to scale. 19 moons are large enough to ground, several having subsurface oceans and one Titan, having a considerable atmosphere. The Moon is by size and mass the fifth largest natural satellite of the solar system, categorizable as one of its planetary mass moons, making it a satellite planet under the geophysical definitions of the term. 17. It is smaller than Mercury and considerably larger than the largest dwarf planet of the solar system, Pluto. While the minor planet Moon Charon of the Pluto-Charon system is larger relative to Pluto, g. 59, the Moon is the largest natural satellite of the solar system relative to their primary planets. H. The Moon's diameter is about 3,500 kilometers, more than a quarter of Earth's, with the face of the Moon comparable to the width of Australia. 16. The whole surface area of the Moon is about 38 million square kilometers, slightly less than the area of the Americas, North and South America. The Moon's mass is 1/81 of Earth's, 60, being the second densest among the planetary moons, and having the second highest surface gravity, after Io, at 0.1654 g and an escape velocity of 2.38 km/s, 8,600 km/h, 5,300 miles per hour. Internal structure. The Moon is a differentiated body that was initially in hydrostatic equilibrium but has since departed from this condition. 61. It has a geochemically distinct crust, mantle, and core. The Moon has a solid iron-rich inner core with a radius possibly as small as 240 kilometers, 150 mi, and a fluid outer core primarily made of liquid iron with a radius of roughly 300 kilometers, 190 mi. Around the core is a partially molten boundary layer with a radius of about 500 kilometers, 310 mi. 62. 63. This structure is thought to have developed through the fractional crystallization of a global magma ocean shortly after the Moon's formation 4.5 billion years ago. 64. Crystallization of this magma ocean would have created a mafic mantle from the precipitation and sinking of the minerals olivine. clinopyroxene, and orthopyroxene, after about 3/4 of the magma ocean had crystallized. Lower density plagioclase minerals could form and float into a crust atop. 65. Final liquids to crystallize would have been initially sandwiched between the crust and mantle, with a high abundance of incompatible and heat-producing elements. 1. Consistent with this perspective, geochemical mapping made from orbit suggests a crust of mostly anorthosite. 15. The moon rock samples of flood lavas that erupted onto the surface from partial melting in the mantle confirm the mafic mantle composition, which is more iron-rich than that of Earth. 1. The crust is on average about 50 kilometers, 31 mi, thick. 1. The Moon is the second densest satellite in the solar system, after Io. 66. However, the inner core of the Moon is small, with a radius of about 350 kilometers, 220 mi, or less. 1. Around 20% of the radius of the Moon. Its composition is not well understood, but is probably metallic iron alloyed with a small amount of sulfur and nickel. Analyses of the Moon's time variable rotation suggest that it is at least partly molten. 67. The pressure at the lunar core is estimated to be 5 GPa, 49,000 atom. 68. Magnetic field. The Moon has an external magnetic field of generally less than 0.2 nanoteslas, 69, or less than 100,000th that of Earth. The Moon does not currently have a global dipolar magnetic field and only has crustal magnetization likely acquired early in its history when a dynamo was still operating. 71. However early in its history, 4 billion years ago, its magnetic field strength was likely close to that of Earth today. 69. This early dynamo field apparently expired by about 1 billion years ago, after the lunar core had completely crystallized. 69. Theoretically, some of the remnant magnetization may originate from transient magnetic fields generated during large impacts through the expansion of plasma clouds. These clouds are generated during large impacts in an ambient magnetic field. This is supported by the location of the largest crustal magnetizations situated near the antipodes of the giant impact basins. 72. Gravitational field. The Moon's gravitational field is not uniform, but on average, at the Moon's surface, it is 1.622 m/s2, 0.1654 g, 5.318 foot/s2, 4, strong. Therefore the surface gravity of the Moon is about half of the surface gravity of Mars and about a sixth of Earth's. The details of the gravitational field have been measured through tracking the Doppler shift of radio signals emitted by orbiting spacecraft. The main lunar gravity features are mascons, large positive gravitational anomalies associated with some of the giant impact basins, partly caused by the dense mare basaltic lava flows that fill those basins. 73, 74. The anomalies greatly influence the orbit of spacecraft about the Moon. There are some puzzles. Lava flows by themselves cannot explain all of the gravitational signature, and some mascons exist that are not linked to mere volcanism. 75. Surface conditions. The surface of the Moon is an extreme environment with temperatures that range from 140 degrees Celsius down to 171 degrees C, an atmospheric pressure of 1010 Pa, and high levels of ionizing radiation from the Sun and cosmic rays. The exposed surfaces of spacecraft are considered unlikely to harbor bacterial spores after just one lunar orbit. 76. The surface gravity of the Moon is approximately 1.625 m/s2, about a sixth or 0.166 of that on Earth's surface, 4, and about half on Mars. Surface temperature. Earth has a pronounced axial tilt. The Moon's orbit is not perpendicular to Earth's axis, but lies close to Earth's orbital plane. Angles of inclination of the Sun-Earth-Moon system. The Moon's axial tilt with respect to the ecliptic is only 1.5427 degree, 877, much less than the 23.44 degrees of Earth. Because of this, the Moon's solar illumination varies much less with season on the Moon, and topographical details play a considerably more crucial role in seasonal effects on localities on the Moon. 78. From images taken by Clementine in 1994, it appears that 4 mountainous regions on the rim of the crater Perry at the Moon's north pole may remain illuminated for the entire lunar day, creating peaks of eternal light. No such regions exist at the South Pole. Similarly, there are places that remain in permanent shadow at the bottoms of many polar craters. 79. And these craters of eternal darkness are extremely cold. The Lunar Reconnaissance Orbiter measured the lowest summer temperatures in craters at the southern pole at 35 K, 238 degrees C, 397 degree F, 80, and just 26 K, 247 degrees C, 413 degree F, close to the winter solstice in the North Polar crater Hermite. This is the coldest temperature in the solar system ever measured by a spacecraft, colder even than the surface of Pluto. 78. Average temperatures of the Moon's surface are reported, but temperatures of different areas will vary greatly depending upon whether they are in sunlight or shadow. 81. Atmosphere. Sketched by the Apollo 17 astronauts. The lunar atmosphere was later studied by Lady. 82. 83. The Moon has an atmosphere so tenuous as to be nearly vacuum, with a total mass of less than 10 tons, 9.8 long tons, 11 short tons. 84. The surface pressure of this small mass is around 310-15 atom, 0.3 nPa. It varies with the lunar day. Its showers include outgassing and sputtering, a product of the bombardment of lunar soil by solar wind ions. 15. 85. Elements that have been detected include sodium and potassium, produced by sputtering, also found in the atmospheres of Mercury and Io, helium-4 and neon, 86, from the solar wind, and argon-40, radon-222, and polonium-210, outgassed after their creation by radioactive decay within the crust and mantle. 87. 88. The absence of such neutral species, atoms or molecules, as oxygen, nitrogen, carbon, hydrogen and magnesium, which are present in the regolith, is not understood. 87. Water vapor has been detected by Chandrayaan-1 and found to vary with latitude, with a maximum at 60-70 degrees. It is possibly generated from the sublimation of water ice in the regolith. 89. These gases either return into the regolith because of the Moon's gravity or are lost to space, either through solar radiation pressure or, if they are ionized, by being swept away by the solar wind's magnetic field. 87. Studies of Moon magma samples retrieved by the Apollo missions demonstrate that the Moon had once possessed a relatively thick atmosphere for a period of 70 million years between 3 and 4 billion years ago. This atmosphere, sourced from gases ejected from lunar volcanic eruptions, was twice the thickness of that of present-day Mars. The ancient lunar atmosphere was eventually stripped away by solar winds and dissipated into space. 90. Dust cloud. A permanent moon dust cloud exists around the Moon, generated by small particles from comets. Estimates are 5 tons of comet particles strike the Moon's surface every 24 hours, resulting in the ejection of dust particles. The dust stays above the Moon approximately 10 minutes, taking 5 minutes to rise, and 5 minutes to fall. On average, 120 kilograms of dust are present above the Moon, rising up to 100 kilometers above the surface. Dust counts made by Lady's Lunar Dust Experiment, INDEX, found particle counts peaked during the Geminid, Quadrantide, Northern Taurid, and Omicron Centaurid meteor showers, when the Earth, and Moon pass through comet debris. The lunar dust cloud is asymmetric, being more dense near the boundary between the Moon's day side